Good evening, everyone. Today we'll be looking at binary tree traversal methods. So, a tree traversal is a form of graph traversal, and it refers to the process of visiting each node in a tree exactly once. Uh, th- Such traversals are like classified into by the order in which the search is done. They are classified into mainly four types. They are like pre-order traversal, in-order traversal, post-order traversal, and level order traversal. So we'll look at all of them one by one. So in pre-order traversal, mm, yes. So in pre-order traversal, we have uh, we have this order, which is like we visit the node first, or like we print the value, then we traverse the left subtree, and then we traverse the right subtree. So in this example, we are at the root node here, which is 0. We visit, we visit the root node, which is v, visit and strike off v, so the output is 0. Then we check for the left subtree, so we are at 1 now. We visit 1 because we are at this, so our output is 1. Then we go to the left subtree again, so we are here. We visit 3, so output is 3 again, 3. Then we go to the left subtree. Do we have a left subtree? Yes. So we are at 7 now. We visit 7, so the output is 7. Do we have a left subtree? No. Do we have a right subtree? No. So we go back. We check on 3. Do we have a right subtree? No. Hence, we go back again to 1. Do we have a right subtree? Yes. So we are at 4 now. We visit 4, so the output is 4. Do we have a left subtree? No. Do we have a right subtree? No. So we go back. V, L, and R all are full here. So again, we go back to its own parent, to the parent of 1. Do we have a right subtree? Yes. So we are at 2 now. We visit 2. So the output is 2. Do we have a left subtree? Yes. So we are at 5 now. We visit 5. So the output is 5. Do we have a left subtree? No. So the L gets cancelled. Do we have a right subtree? Yes. So we are at 8 now. We visit 8. So the output is 8. Do we have a left subtree? No. Do we have a right subtree? No. So we go back to its parent. VLR or are complete. So we go to the parent of 5, which is 2. Here we see that R isn't complete. So do we have a right subtree? Yes. So we are at 6. So we visit 6. V gets cancelled. So the output is 6. Do we have a left subtree? No. Do we have a right subtree? Yes. So we are on 9 now. We visit 9. So the output is 9. Do we have a left subtree here? Do we have a left subtree here? No. So L gets cancelled. Do we have a right subtree here? No. So we trace back to its parent. V, L, R all are complete. We trace back to its own parent, which is again V, L, R all are complete. Then we go to the finally we reach the root node, which is where we again see that V, L, and R is complete, which concludes that we have searched the tree. So the output is 0, 1, 3, 3, 7, 4, 2, 5, 8, 6, 9. Now we'll look at the next type of traversal, that is in order traversal. So first, again, we start at the root. Do we have a left node and left subtree? Yes. So we are on 1. Do we have a left node, left subtree of 1? Yes. So we are at 3. Do we have a left node of 3? Yes. So we are on 7. So the out. Then do we have a left node of left subtree of 7? No. So we visit 7. So the output is 7. Do we have a right subtree of 7? No. So we come back here. We visit 3, since next is V here. So we visit 3. Do we have a right subtree of 3? No. So we go back to 1 again. We visit 1 here. So output is 1. Do we have a right subtree of 1? Yes. So we are on 4 now. Do we have a left subtree of 4? No. So we visit 4. Output is 4. Do we have a right subtree of 4? No. So we go back to 1, the parent of 4. We check here that LVR is complete. So we go back to the parent of 1, which is again which is 0. We have V here, V left. So we visit 0, which is output is 0. So now we check for R, do we have a right subtree? Yes. So we are on 2 now. For 2, do we have a left subtree? Yes. So we are on 5 now. For 5, do we have a left subtree? No. So we visit 5. So we print 5. Do we have a right subtree of 5? Yes. So we are on 8 now. Do we have a left subtree of 8? No. So we visit 8. Output is 8. Do we have a right subtree of 8? No. So we go back to the parent, LVR, complete. It's complete here. Then we come here. We see we haven't visited 2 yet. So we output 2 here. Do we have a right subtree of 2? Yes. So we are at 6 now. Do we have a left subtree of 6? Yes. No. So L gets cancelled. So we visit 6. So the output is 6. Do we have a right subtree of 6? Yes. So we are on 9 now. Do we have a left subtree of 6? Left subtree of 9? No. So we visit 9. So the output is 9. Do we have a right subtree of 9? No. So LVR is complete here. We go to the parent of here, parent of 6, which is again we check that LVR is complete here. We go to the parent of 6, which is 2. Here also LVR is complete. We go to the parent of 2, which is 0. We check here LVR is complete. And the parent of 0, parent 0 has no parent because 0 is the root. Hence, we can conclude we have traversed this tree. And the output is 731405826 9. Now we'll look at the other type, third type, which is the post order traversal. So we start at the root as usual. We see, does 0 has a left? Yes. So we are on 1. Does 1 has a left subtree? Yes. So we are on 3. Does 3 have a left subtree? Yes. We are on 7. So does 7 have a left subtree? No. Does 7 have a right subtree? No. So we visit 7. So the output is 7. We come back to 3 again. We check if 3 has a right subtree, which is no. So R gets cancelled. So we visit 3. So the output is 3. LRV is complete. We go back to 1 again to the parent of 3, which is 1. Do we have a right subtree? Yes. We come to 4. We check for, does 4 have a left subtree? No. Does 4 have a right subtree? No. So we visit 4. Output is 4. We go back. Now we say check here that V isn't we haven't visited 1 yet. So the output is 1. Visited 4. LRV is complete. We come here. Now we haven't checked the right. So we strike out. We have a right subtree of 0. So we are on 2 now. Do we have a left subtree of 2? Yes. So we are on 5 now. Do we have a left subtree of 5? No. So L gets cancelled. Do we have a right subtree of 5? Yes. So we are here now. Do we have a left subtree of L of 8? No. Do we have a right subtree of 8? No. So we visit 8. So the output is 8. We go back. LRV is complete. So we go back to the parent of 8. We visit 5. So the output is 5. Then once LRV is complete, we again go to the parent of 5, which is 2. Do we have a right subtree of 2? Yes. So we are on 6 now. Do we have a left subtree of 6? No. L gets cancelled. Do we have a right subtree of 6? Yes. So we are on 9 now. Do we have a left subtree of 9? We have no. So it's L gets cancelled. Do we have a right subtree of 9? No. So we visit 9. So the output is 9. We go back to the parent of 9. So and it is we say we haven't visited 6. So we print 6. We go back to the parent of 6, which is 2. We haven't visited 2 yet. So it's 2 output. Then we go back to the parent of 2, which is 0. And we strike out V and print 0. We visit 0. And since 0 again is the root, it has no parent. So we can conclude we have completed the traversal. Hence the output is 7341859620. Now we'll look at the other type. Now this is the easiest one. to understand, this is the level order traversal, in which we have like the levels of the tree. We divide the tree into its levels and we print level by level. So in this is level 1, this is level 2, this is level 3, this is level 4. In level 1 we have 0, then in level 2 we have 1, 2, in level 3 we have 3, 4, 5 and 6, and in level 4 we have 7, 8 and 9. So this is just that way. Now let's like compare all these four types of searches, all four types of traversals. Okay, so you see for the same tree, we have different outputs for pre-order traversal, in-order traversal, and post-order traversal, and as well as level order traversal. Thank you.